This is our Unit 8 Day 3 video, and we're talking about today is the difference between explicit formulas and recursive formulas, or recursion equations. So there's different ways we can write sequences, which what I've been talking about the past 2 days is sequences, sequence notation. There's explicit formulas, which tell you how to find the nth term or the general term. So you can take the term number which is what we call n. You can take the term number n and find the nth term directly without finding all the terms that come before it. So you don't have to find all the terms that come before the nth term. You can just take that term number n and plug it into a formula and find that term directly. Right, so one thing you ask yourself is, if I was asking you to find the 100th term, right, if you have an explicit formula, that's no problem. So example of what an explicit formula would look like for sequence would be something like this: an equals 2 to the n. Alright, so whatever the term number is, I take 2 raised to that power, and that's my nth term for that sequence. So recursive formula or recursion equation is different. It uses the previous term to find the next term. And the previous term is what we call a n minus 1 using our sequence notation. So use the previous term to find the next term. Which is an. So for a recursion equation or recursive formula, you have to start at the first term. You have to start at a1 and then find every term up to an. So for this one, if this is the one where you saw the question was asking you to find the 100th term, and you had a recursion equation, your answer would be hell no. Right, so think about that question. If you don't know if you have an explicit or recursion equation, would you actually go through and find the 100th term? So an example for what a recursion equation looks like would be an equals 2 times a n minus 1. And then you have to have the first term given to you, tells you a1 is 2. So these two, even though they're two different formulas, one is recursive and one's explicit, these actually describe the same sequence. If we go through and just find the first 4 terms, right, using either formula, we can see if I plug in 1 on the left for the explicit formula, 2 to the first would be 2. It tells me right here on the recursion equation that the first term is 2. Right, then my second term on the explicit formula would be 2 squared, which would be 4. Same idea. With my recursion equation, I take the previous term 2, multiply by 2, I get 4, so same thing. Right, my third term in both would be 8, fourth term would be 16, etc. So it's the same sequence, there's just two different ways of writing it. There's the explicit form, and there's the recursive form. So here's an example. We're finding the first 4 terms of the sequence, and here we have a recursion equation. We can tell we have a recursion equation because of this term right here, an minus 1. That tells us this is a recursion equation. So we're going to have to find all these terms. That's what we're doing anyways, find the first 4 terms, but we wouldn't be able to jump and find the fourth one right away. We'd have to find all of them on the way there. But it's asking us to find the first 4 terms. We'll just go through how we use a recursion equation. So we know our first term is given to us. A1 is 5. So what we're going to do after that is we're going to take the previous term, multiply it by 3, and add 2. So to find A2, I take A1, which is 5, multiply it by 3, and add 2. So that's 15 and 2, 17. So then to find A3, I'm going to multiply that previous term, 17, by 3 and add 2. So that's 51 and 2 is 53. Right, and same thing to find the fourth term. Take that 53, multiply it by 3, which should be 159, add 2, I get 161. So each time I'm using the previous term to find the next term. Right, that's what the recursion means. So next we're going to find the first 4 terms of the sequence again, another recursion equation. So again, we're going to start with that first term. It's 3. My rules tell me I take the previous term, multiply it by 2, and then add 5. So to find A2, I'm going to multiply that 3 by 2, then add 5, which would be 6 and 5, 11. Same idea for the next one. Now I'm multiplying that 11, the previous term, by 2, and adding 5. So that's 22 and 5, 27. Now, same thing, find the fourth term, take that third term, multiply it by 2, and add 5. So 2 and 27 is 54, and 5 is 59. So same idea again, we're starting with the first term, and we're using the previous term to find the next term following the recursion equation. So now we're going to take a sequence and we're going to write both an explicit and a recursive formula for the sequence. And we're going to learn some other ways of doing this in the next couple days, but we'll go through just basic recognizing the pattern, what's happening every time. So we'll start with the recursion equation. Usually it's easier to see how the terms relate to each other than they relate to the term number. So what's happening every time? What is the pattern? That's what we're looking at for the recursion. What is the pattern? So we go 7, 11, 15, 19, 23, 27. What we're doing, what our pattern is, that we're adding 4 every time. Right, so that's one of the pieces we need for recursion. The other thing we need to know for recursion is, where are we starting? Right, what's the first term? What is A1? Right, we look at this sequence here, it's starting at 7. And so that's everything I need to write my recursion equation. From this bottom two pieces, I know A1 is 7, and from this top piece, I know to find AN, I'm going to take AN minus 1 and add 4. And this is my recursive formula. So the explicit formula is a little more difficult. We'll go over some different ways of doing this, but for explicit, we're trying to see how we can relate the term number to the term itself. So instead of what's the pattern for each next term, it's how does the term number relate to each term. So how does N relate to AN? So for this one, we want to rewrite our sequence here with term number and the actual term itself, see if we can see a pattern. So our first term is 7, second term is 11, third term is 15, fourth term is 19, fifth term 23, and then sixth term is 27. So one thing we notice between our terms that we do have a constant change. It's changing by 4 each time. Right? It's going up by 4. So we have a constant rate of change. We know from all the functions we've looked at in this course that that is a linear function. Right, so a linear function is something that looks like y equals mx plus b. M is the slope, and b is the y-intercept. So in this case, since our constant change is 4, that's our slope. So we just have to find what our b is. Well, if we look at 4 times 1, we'd have to add 3 to get to 7. 4 times 2 is 8. Again, we add 3 to get to 7. 4 times 3 is 15, and again we add, 4 times 3 is 12, and again we add 3 to get to 15. So it's going to be 4x plus 3, right, as our linear equation. Then that becomes our explicit formula to get from the term number directly to the term. Multiply term number by 4 and add 3. And then last one we're going to look at is explicit and recursive formula for this sequence here. So 1, 1/4, 1/16, 1/64, 1 over 256, and keeps going like that. So again, what's helpful about recursive formulas are a little easier to get started, right? So I know first thing I want to look for is the pattern, and then I want to look for where it's starting. Right, so where it's starting is pretty easy. It's starting at 1, so I can even go ahead and write that in on my recursion equation. Alright, second piece, what's the pattern? I go from 1 to 1/4, 1/16, 1/64. I notice the denominators of these fractions are powers of 4, so I'm doing is I'm multiplying by 1/4 every time. Right, so I start at 1, and then my recursion equation to find an, I take an minus 1, and I multiply it by 1/4. Right, or I could rewrite that as an minus 1 divided by 4. So there's my recursion equation. So for my explicit, again, I want to look at the relationship between n and an. How does the term number relate to the term? So our first term is 1, second term is 1/4, third is 1/16, fourth is 1/64, and our fifth term is 1/256. Where I see that as I'm moving one term to the next, I'm multiplying by the same thing every time. So there's a constant ratio or multiple. And again, from the functions we've looked at, we know this should represent an exponential function. Where we have the exponential function with base 2, we multiply by 2 every time. Base 3, multiply by 3 every time we go up 1. Base 5, multiply by 5 every time we go up 1. Here, our base would be 1/4. We're multiplying by 1/4 every time we move to the next term. So we know we're going to have an exponential with 1/4 as the base. We just have to figure out how we can relate the term number to that exponent. So 1/4 to the 0 power is what makes 1. 1/4 to the first power is what makes 1/4, but the term numbers there are 1 and 2 respectively, so it's actually 1 less than the term number. So to convert this into my explicit formula for the sequence, right, it's not n that I'm raising to, it's n minus 1 that I'm raising 1/4 to. So for my first term, I'm raising 1/4 to the 0 power, second term to the first, third term to the second, and so on. If you want to see more examples of these types of problems, you can search on YouTube for explicit and recursive formulas.